All right. Hello, everybody. I hope you are doing well. Welcome to the stream. Spiro first on both sides, I see. What's going on, buddy? Good to see you. So, we are going to pick up where we left off last time, and we actually have a lot more updates to go over, and we have a really big milestone that we're hitting today. So, good news there. But before we jump into that, I want to take just a quick second just to thank the supporters of the channel, beginning with our elite partner, who is the highest tier over on Patreon and YouTube memberships. That is Javier Olazaron. I'd also like to thank the partners, Gorbolis Inc. and Matt Oscard. That is the next tier there. And I would also like to thank the list of other supporters here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me offset costs associated with running the channel, the project, things like hosting fees, software licenses, stuff like that. So thank you guys very much for your support on there. And I would also like to thank all of you, the viewers, whether you're catching this live, either on the YouTube side or the Twitch side. We do simulcast to both. Or if you're just catching the VOD after the fact, I thank you guys for being here. Without you guys, this project would not exist. So, anyway. So where we left off last time was actually on the audio system. And I have some really good news about that. First time chatter, by the way, Ramon. Hello from Spain. Really late, but I'll try to watch a little. I appreciate you sticking around, and welcome. I hope you're doing all right over there, except for being a little tired, because I think you guys are, 6 hours ahead of us? I'm on Eastern Standard Time, so. Or I guess it's daylight savings time now. All right, so where we left off last time was we were in the middle of an audio system refactor, and we got most of the way there, but just not quite enough to actually see it come to fruition. So I went ahead and finished that offline just so that we can actually move forward and get to some new stuff tonight. So the audio refactor is done, and I also did a lot of troubleshooting and bug fixing offline. So what we're going to do is I'm actually going to launch this real quick. And I'm actually going to pause the music just for a second so that you guys can hear. The music you're hearing now, at least I think you guys should be able to hear it, is now coming from the game engine. So it looks like on my monitors here, you guys should be able to hear that. So I've resolved a lot of bugs and stuff offline. I went ahead and got the sound system working, and the music you hear is playing in what I call 2D, right? It's just playing sort of over top of everything. And then we also have, if I go ahead and load up the scene here, we also have a test sound that is playing at the scene's origin. So it's 000, so it's right here. You probably can't hear it now, but if I go a little bit closer, you'll hear that come in. And that's the sort of fire sound that you're hearing there. And so that is spatial sound. So if I turn the camera left and right, you guys should be able to hear that panning sound left and right. So our spatial sound is working again. And so what we'll wind up doing tonight is extending that a little bit further. And we're going to make a proper audio emitter. In the old version, we kind of had like a struct that we sort of hacked in. And wasn't really connected to the scene, and we kind of just simply controlled it with gameplay code and stuff like that. We're going to go ahead and make an actual audio emitter that actually has, can be placed in the world and things like that. And we're going to tie that into the sound system and get that going. But before we do that, I'm going to go ahead and quit this out. Before we do that, I'll go ahead and mention that since the audio system has been refactored, we actually have nothing left on the to-do list for 0.8.0. And so I did a lot of bug fixing and a lot of miscellaneous things offline, and so you guys will be able to see that in the commit. But I am actually going to go ahead and take this massive branch that we've been working on this entire time, and we're going to go ahead and get that merged back into the 0.8.0 branch. And we are going to close the refactor down, right? We're actually at a point now where we're going to be adding new stuff. So I've ripped all the old audio stuff out. All that's completely gone. It's been replaced with the new audio system, except for a couple of things that we have to re-implement in the next release. All of the assets, all the resource stuff has all been re-implemented using the new system. So I've punted a couple things off to the next release so that we can actually start working on the game, but we are going to need sound emitters for that. And so I thought that would be kind of a new little feature that we could take a look at where we haven't really done that thus far. And I did notice that we are going to have to add something to the sound system. So I'll go ahead and explain the sound system to you guys as we do that so you guys know how that works. And of course, there'll be documentation forthcoming. But that's kind of the plan for tonight. We're going to put in sound emitters. But, like I said, before we do that, I want to go ahead and, let's see, I can pull that on this one. All right. So, all right. So what I've got here is I'm going to go ahead and create a pull request to merge the feature K package into release. Boy, did I name that branch wrong, right? That was supposed to be like a small thing that I was going to be adding, and it wound up turning into me basically rewriting all of the asset and resource handling. But I digress. And so what we're going to do is we're going to merge into that. And so I'm going to go ahead and just create that pull request. And we can see that we have 100 commits in there, 637 change files. Now, mind you, most of those change files are assets and us moving assets around, right? There's hundreds of assets in our test. But yeah, we're definitely finally ready to do this. Let me catch up on some chat over here. 3D Code Warrior, how's it going? Good to see you. Ramon, 6+ hours difference. Yeah, sounds about right. RCW, good to see you. Let's see. Maget's, good to see you as well. Welcome. Spiro says, I want to be like you when I grow up, man. Holy crap, you're a magician. I'm pretty sure Zeus skipped my Greek heritage and went straight to you. I don't know about Zeus, man. I don't want to be Zeusing things. Especially not my computer. That gets expensive. I appreciate the compliment, though. Yeah, so this is pretty exciting, for sure. I'm definitely looking forward to implementing new stuff now. LaFoley, good to see you as well. Little Carlito says, well, I sent her 2 divs in React yesterday. Easy. You're cooking now, as Spiro says. Yep, I agree with that. To center yourself in the universe, you must first center a div. Yeah, especially vertically. Yeah. Zeus-oriented programming, ZOP. I like Dingus-oriented programming better, though. Dingus-oriented programming is where it's at. It's what we do. All right, so this is literally like the culmination of about 6 months worth of refactors. And actually, what's really hilarious is like it doesn't even list out the entire list of commits, right? So I'll leave all of this in here. I'm actually not going to squish these commits just because there's so much in here. I'm going to go ahead and leave them in place and just merge this as is. Let's see. Continuous integration has not been set up. I need to do that eventually. I do not want to squash a merge. We want to do a merge commit. And I don't think I need to add anything. That should be good to go. Let's go ahead and merge it. Confirm. And I'm going to nuke the branch. So we are finally merged into 0.8.0. So we can go in here and let's see, I'm actually going to have to do a new thing here. Let's see. So git checkout release 080. Got to update all those files. That's how large of a branch this is. And I'm going to pull, because there's no way it's up to date. Right, and I'll print those branches later, the dead branch. But for now, we are on 080. So what I'm going to do over here is switch back to here. Just reopen these things just to make sure that our buffers are up to date. I'm going to do a clear, or a clean rather, and I'm going to rebuild debug. Ruche, thanks for the on-screen celebration. Appreciate that. Appreciate the bits. Let's see. All right. So, before we actually cut to this new feature, we are going to keep our. I do want to talk about kind of how we're gonna move forward. This is the last time we're going to have a branch that large. I don't like doing that. It was kind of necessary because of the scope of changes we had to do, but I want to keep feature branches much smaller going forward. So I think I'm going to cram audio emitters into 080. I don't think I'm going to cut the release just yet. I think we'll cut it after we finish that, but I'm going to create a new branch off of that. So we're going to do feature, if I can spell. We're going to call this audio emitter. All right. So now we're on that branch. And what we're going to do is we're going to take a look at the audio system really quickly. And we're going to kind of go over how this is set up. And I've got some comments in here I need to add as well. So I refactored the audio system to make it match a little bit closer to the way that the renderer works, where we have a front end and a back end. And that is because we can have multiple audio backends, right? So the audio front end is similar to how the renderer works. It's what the rest of the engine interfaces with and understands. So this is the API that the rest of the engine uses, and it does not care what is behind the scenes in the back end. The back end is, again, similar to the renderer, is a plugin. In our case, we have one single plugin for audio right now, which is an OpenAL audio plugin. So that's where the back end lives. We'll get to there in a minute. So essentially, I'm trying to keep the front end interface as light as possible here, right? So we have our typical system initialize and shutdown and update. And then we also have a few getters and setters types of functions, and the reason that we have those will become apparent in a bit. So the most important ones here to mention are audio system listener orientation set. We kind of had this in our old system, so that's been carried over. Essentially what you do is you set a position where you are in the world, a heading, so your forward vector and an up vector, right? So these just match what our camera already has. So we can literally pull our view orientation and have the data we need for that. So that is continuously set every update. And so that is something that gets called all the time, right? So as we move the camera around, that's how you can hear the panning and whatnot of the 3D sounds. Next, we have a master volume getting set. That should be pretty self-explanatory. So that controls the volume over everything, right? And then we have channel volume set. So channels are, there's a finite number of channels that you can play audio over. And each channel can only play one particular thing at a time. So you can play music on one channel. You can play sound effects on the other 7 if you have 8, right? The default number of audio channels, by the way, is 8. Typically, most devices support like 16. and that is a configurable item. So we have settings that get set per channel, right? So all you do there is you say, I want to set the audio for channel and then index, 0 through 7, for example. And then to the volume, which is a range of 0 to 1 inclusive. And of course, get just retrieves what that actually is, right? And so the audio system is also sort of a state machine, right? And so we have that, and then we have individual audio resources, right? And these work, again, kind of similar to some of the way that our renderer resources work. So we have a acquire and a release. And what this does is it takes in a resource name, a package name, and that is what actually kicks off a request to the resource system to load up an audio resource. And we'll get into audio resources here in a minute. And then we indicate whether or not it is a streaming resource. And what that means is basically, is it a long audio file that should be only pulled in bits at a time, or is it a quick file that's very small that we can just play the whole thing all in one shot? And so generally for music, you would want to use streaming. For sound effects, you would not. And then, of course, we have a pointer to a handle that is returned. So the actual audio resource itself is not exposed to the rest of the engine, nor is any of the underlying data. And so sort of some of our previous data structures had that problem. There was a lot of crisscrossing and whatnot. And all of that's been eliminated. This entire system works through handles now. And so that is that. So we have the acquire, and then of course we have the release, which I actually named this instance because I was thinking about doing instances, and we don't actually need those. So that should actually be, that should just be called audio. Right? Okay. So we have acquire and release, and then we have the ability to play. And all we do here is we pass through, obviously, a handle to an audio thing that we want to play. Whether it's streaming or not doesn't matter at this point. It's just a handle to an audio resource, right? And so we pass that, and then what channel index we want to play it on. And of course, there's checks that happen within the audio system to be able to handle that. We also have a valid check. This can be used to see if a audio resource is actually loaded and able to be used. So there's that. And then we have pitch, volume, and looping set. So pitch basically just allows you to set the pitch on a particular sound. So you can pitch things up and pitch them down. We have a volume for the individual sound itself. So each sound can actually have a volume of its own. And then the looping basically says when the sound clip, whether it's streaming or not, reaches the end, does it rewind back around to the front and keep playing or not? And so you can get or set that. And then we have all of our individual channel. Let's see, we actually have... I just realized I have this in here twice. I probably don't need that in there twice. This should really be down here with the other channel things, which I already have here. So there's an issue. But essentially, audio channel play. If an audio channel has already had a sound assigned to it, then you can go ahead and just play that again, which is probably not something we'll use very often, but it's there. We can also pause a particular channel, or we can resume a pause channel, or we can stop a pause channel. So stop versus pause. Pause basically retains the position of the audio on that channel, whereas stop basically rewinds it, right? And then we have checks for is playing, is paused, is stopped. Then we can actually set channel looping and channel volume. The channel looping I might get rid of because it's a little bit confusing. I exposed it because that's kind of the way that it works under the hood, but I might wind up getting rid of this one. But then we also have channel volume get and set. So the reason you would want this is if you have different channels in your game. say one channel that you always use for music, right? You want to be able to have like a volume slider just for your music, right? That needs to have a channel of its own. We need um, to be able to set that volume on that channel by itself. And so generally, the way that most things would be set up is we'd have a single channel for music, and then we might have another channel for, say, UI effects or something like that. And then we might have other channels just for sound effects, for example. And we can split it up however we want. We can get as granular with it as we want. And it really just depends on, what channel you play what on when, and what that volume is set to. So those are the settings there. One thing that we are missing that we're going to need for our emitter, and so we'll implement that tonight as well, so that we can get an idea of how all this stuff gets passed through. Is we don't have any way to set the position of an audio resource, right? Which is obviously going to be needed for an emitter, right? So we're going to need to be able to do that. And then that, of course, interacts with the listener orientation. So a couple things to keep in mind, too. So only sounds that are mono instead of stereo can be spatial, right? If an audio clip is stereo, it automatically is what I call a 2D sound. It plays on both sides, and you cannot position that in space. If you want to position it in space, it's got to be a mono sound. All right, so that is pretty much the way that the front end works. All right, let me catch up on chat because I suspect there are questions. Was wondering what the benefit of using a float value for volume when working with the WinMM API was. With the WinMM API volume was set with an unsigned int. So I mean, we could use anything we wanted, right? We don't have to use floats for it. I just find them a little bit more intuitive. We could, if we wanted to, use ints, right? But OpenAL under the hood actually uses floats, so we'd have to convert that under the hood anyway. I may wind up using like an unsigned integer eventually to set volume. I haven't really decided yet. I went with floats now because it was easy to pass through. There's not really a benefit or drawback to it, really. It's just 0 to 1, right? But if I were to use an unsigned 8-bit integer, right, 0 through 255 for the audio, maybe that would be a little bit more intuitive. Or maybe we just say it's 0 through 100, right? So we'll have to pick a range and scale it accordingly. All right. Let's see. Thank you for the follow, by the way. That was 6 minutes ago, but thank you for that. Lazy Man, I'm doing well. How about you? I am on Windows today, yes. My Linux install is having a little bit of an annoying issue with my graphics driver, where it'll just kind of hang up for a good 10 seconds every once in a while. And I haven't really figured it out, so I've come over here to Windows land for a bit. Just because I don't want that to happen on stream. And it's not my application causing it. It happens like when videos play or anything that even might be even slightly GPU intensive. So haven't figured that out yet, but yeah, but I'm usually not on Windows. I just am for the stream because I don't want it to hang. You guys probably saw that in the last stream, actually. Dingus, yes. Are you using something like OpenAL for sound or your own platform-specific implementation for each platform? So I thought about, that's a good question, Nivimi. I thought about doing separate implementations at the platform level. But then I thought, I'm like, well, there's not really much value, right? That's already kind of like a solved problem. So I'm using OpenAL for now, but I suspect that we're also going to want to use things like we'll probably eventually have like an fmod plugin and maybe other sound systems that exist out there as well. So yeah, we do have one plugin for OpenAL for now because that was quick and easy to implement, but we'll probably have others. You're still waiting for the Dingosaur emote? I'm still waiting on somebody to make a Dingosaur emote because I have no idea what that would look like. Why not mix it down to mono? Are you talking about the music? Because if that's kind of the way that OpenAL works in general, and I kind of like that a little bit. I like the way that that works because then I don't have to mix it down to mono, right? Can you change a sound's velocity? Yes, you can. I don't have that exposed at the moment because I have to kind of figure out how to use it, but OpenAL does actually have that, yeah. Sergeant Pepper, how's it going? Good to see you, man. Got degenerates in the chat, Spiro. That's funny. F mod, you hear that, Spiro? F mods. Stereo audio. Yeah, so I kind of like the fact that when you have an asset that plays in stereo, right, it's a 2D sound versus not. Now, I suppose I could add something to downmix it, right? Maybe as an option. And then we could say, well, do we want this to be a 2D sound or a 3D sound explicitly? But yeah, it's a little bit more work. That would be an enhancement. I'm not opposed to it. I just don't have it yet. All right. Let's see. Singy, good to see you. How's it going? Do you have any tips for API design in C and dealing with generics beyond void pointer? Generics are kind of a tricky thing, right? You usually almost always have to do it with macros in C, which is why I don't do it all that often. The only thing I really do it for is our dynamic array. And it does use void pointers under the hood, but the way that we have it is we have this sort of backing function that creates a D array for us, which has got like a header that has the length, the stride, and all that stuff in it. And obviously the backing memory. And then what we do here is whenever we create a D array, we have a D array create macro that takes in the type. And what this does is it calls that underlying function, and it uses the size of the type to, to actually allocate the underlying memory, and then it casts it back to type pointer when we create that. So it kind of gives us a little bit of that. But yeah, I mean, it's not a perfect solution either. It works good enough for what we need here, but yeah, I mean, I would say other than something like this, you don't really need generics, right? Just don't do that. This isn't really a language where you use generics, right? That's more of a C++y thing with templates. So yeah, generally speaking, I would try to avoid doing that. The only other thing that I would say is sometimes you can get away with sometimes you can kind of get away with a little bit of typecasting to get what you need. So if we take a look at, let me see, is K-resource a good example? It would be a good example if I had that set up right. I think asset types is a better example. I thought, anyway. I don't know if this is a good example either, but yeah, let's go with resources. That's a better example than assets. Sometimes what I'll do is if I have something that I need to sort of fake an interface or inheritance, and I use those terms like lightly, right? Because that's not really what we're doing. But for example, if we have something generic like a K resource, right? That has properties that every resource is going to have. I'll create that, and then I'll set this struct up to be the first member of something that uses it. So if we scroll down here a little bit further, we've got a K resource texture, which is a specialized K resource, right? And the very first member of that is a K resource base. And so that means that we can take this thing and cast it to a K resource, right? And so we get a little bit of that through there. So that's another way that you can kind of get around it, where you could just pass K resource pointers, and then you can examine, the K resource type and then cast it to the type you need, which is usually pretty quick because it's just a switch statement at that point. I hope that kind of answers the question. All right, Soundcraft and sound. Wow, the sound system in Minecraft is awful. I want to rewrite it from a mod, but I'm too lazy for that. Implemented for each in your DRA interface in my toolkit, pointer arithmetic, and compiler magic. Yeah, I thought about doing that a few times. I'd probably just never use it though. I just like boomer loops, is what they call them. It's usually what I wind up defaulting to, anyways. All right. So, with that, let's talk a little bit about what an audio resource is and how it works. So I'm going to be very brief with this. I guess the best place to go is probably into our acquisition, right? So audio, front end C. So if we take a look at acquire, what we do here is we essentially set up some internal resource stuff, right? We use our handles. So we have an array of these K audio resource handle datas, right? Which is what actually keeps a pointer to the underlying resource, as well as some state information for it, right? So that's where this pitch and volume and looping, all those properties stay for a particular sound. That's where those are stored. So all we do here is a standard resource request of an audio asset, right? So we just kind of fill out the struct and do the request. We do not support hot reloading for audio. So that's an important distinction there. But when that audio asset is loaded, what we do is we go ahead and, of course, save off a pointer to it. And then we call our backend resource load, right? And that's what calls into OpenAL and does what it needs to under the hood. We'll go into that in just a second. And then, of course, if it fails, we release the resource, blah, 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 blah. Okay, so there's that. And then if we take a look at all of our individual setters, right? So our channel volume set, for example, first of all, we make sure that the channel index that was provided was within range. And then all we do here is we set the volume, right? So we say channel sub channel index dot volume, and then we clamp that value and we set the volume that was passed in. Now, how does that actually make it to the backend? We'll get into that in a second, right? So we have a get here, which just returns that state. So the front end just holds a generic state, right? It doesn't actually, at this point, it doesn't actually reach out to the back end to actually do anything in terms of updating OpenAL or whatever it may be in the background. So what that does is, if we actually look for update, during the update, we actually sync all of these properties, right? So for each individual audio channel, if it has a sound bound to it, right? So each channel has something called bound data. Then we go ahead and perform all of these what I call sync operations. So bound data is just a pointer to some of that handle data that we were just looking at, right? And of course, channels, much like sounds, also have their own properties. So we have a pitch, we have a position of the sound, which again hasn't been exposed. We need to fix that, and then whether or not it's looping, right? So there's a master volume, channels have volume, and individual sounds have volume, right? And so what we do is whenever we are updating the channel, we actually mix that volume, right? And I don't know that this is 100% right, but it seems to work pretty well. So what we do is we take the bound data volume and we multiply it by the channel volume, and we multiply that by the master volume, right? So it applies the volumes across the board and sort of multiplies them together, and that gives us our mixed volume. And then we reach out to the back end at that point and set what's called the gain, which is not exactly the same as volume, but that's how we're treating it in the system, right? And so that is how that gets applied there. Pitch is mixed in a similar fashion. There's no master pitch, right? There's only channel and data, bound data rather. And then looping is only ever set on the channel, right? And we only allow that for non-streaming resources, right? Otherwise, we don't need actually a looping setting to be passed through, and we'll get into why that is in a minute. But looping is a little bit weird in the way that OpenAL handles that, and so we have to sort of be cognizant of that in the front end, but we can also design our other backends to sort of function the same way. And then position is only applied for mono sounds because they can use spatial positioning, right? So we check to see if the resource has one channel, and then we do position set on that based on the channel position, right? Which is actually, I'm actually rethinking the way that that's going to work too. So we're going to probably wind up changing that tonight as well. Because again, I haven't quite fully figured that out yet. Okay, so all of these happen every frame, and we're constantly just applying those updates. That way if stuff's moving, it's constantly getting updated. And it's not really expensive to be applying those updates all the time, so I'm not really too worried about that performance-wise. All right, looks like I've got some comments to catch up on. Wanted to try my hand at making some data structures for my convenience, but wasn't sure how to deal with generics. Just remember relying on some dude's hash map implementation for one of my projects and just kind of want to replace it with my own even if it probably won't be as good. That's fair enough. So one thing that I've started doing is in my generic data structures, is I'll separate the data structure from the actual data. And what I mean by that is, take for example the U64 binary search tree that I have, right? That only deals with indices, right? So I'll actually have a array of the actual resources, a flat array of the actual resources somewhere. And what I'll do is I'll find a free index for that, and I'll say, okay, now the key that I want to look up, which is usually a K name, right? I'll say, okay, the K name is the key, right? And then the actual resource itself is just an integer, which is an index into that resource array. So when I go to do a lookup, I'll say, okay, binary search tree, what do you have in this for this particular key? It'll give me that index, and then I use that index to look up into the array. And that keeps it nice and decoupled and flexible, so that I don't have to have a billion different binary search tree types. I could just have one that deals with integers and then have it perform a lookup into an array. Works pretty well, I think. All right, let's see. Shine up, first time chatter, welcome. Thank goodness you are online. I hope to find someone with experience in the software industry who could provide feedback on whether the material I'm studying is genuinely useful or nonsense. What are your thoughts on component diagrams? Have you ever used them or any other UML designs, excluding class diagrams, sequence diagrams? Do you believe these are useful? Unlike other others such as use cases, activities, components. Okay, so I'll keep this somewhat short. I don't use it a whole lot. I use it when I need to, but I don't find those things particularly constructive. That being said, I think knowing how they work and understanding how to make them is a good thing. Because sometimes that is needed to communicate with other people, right? So if you're working on a project with other people, it's good to know those skills and to know how to do those things. Just because I don't use them here on my personal projects doesn't mean I've never used them at work, right? I've had to use those at work, so it is a good thing to know how to do, even if I don't personally find it all that useful. Sometimes other people do, and you have to sort of, on occasion, tailor what you're doing to help the other people that you're working with understand it in the way that makes sense to them. I hope that makes sense. Boomer loops can easily be optimized by a compiler. In a for each, you must use a pointer and arithmetic on the heap, so a compiler can't optimize it. Yep. That's why I like boomer loops. Can you provide your NeoVim config, please? Yes. That should give you a link. And that is an article that is on my website that also has a link to a GitHub page that has it there, but it explains like all the plugins and stuff I use. Time to go to bed. Have a good coding night. I appreciate Ramon. Have a good one. All right. So, where was I? So I think we've talked about most of the things in here that are kind of necessary, right? So I do want to talk about assets for a second, resources and assets. So let's take a look in runtime, right? So under assets, under source assets, we have a new handler for audio, right? And that's a binary format. We'll get to that in a second. So we have that. Under audio, by the way, is our audio front end and our K audio types. This is the new sound system front end. And then under K resources, we also have a handler for audio, right? To load up audio resources. That being said, we have eliminated the STB Vorbis and the mini MP3 out of the runtime, right? They no longer need to be here. I think they're actually still here, but nope, they're not. Okay, so they no longer need to be here because they are actually included in an importer. So we've actually changed the way that this works a little bit. That's a plugin. It's going to be under plugin utils, right? So this is our importer. We now have a audio importer, and then you'll see here we also have the mini MP3 and the STB Vorbis libraries here. So in these two cases, I'm okay with using a library to parse these because that's kind of a solved problem and not something that I think is super valuable to do on stream, right? Decoding Vorbis files and MP3 just doesn't really make a whole lot of sense to me. These are known good libraries. They work well. I'm okay with using them in this case. So essentially what we wind up with is we have that importer, and it takes source format assets and imports them into our final format. So if I collapse a couple of these here, what we wind up with, if I go here to assets, and we've got some in sounds and some in music. So we have a KAF file, which is Kohi audio file. That's a binary format that we've come up with. And it's just got a simple binary header and then all of the audio data in PCM format in there. So it doesn't matter whether you're importing an MP3 or whether you're importing an OGG Vorbis file or eventually a WAV. It's all going to be converted into the same format that the engine understands, and then the engine doesn't have to worry about all that decoding and all that stuff going on the fly. It's already all done for it, and it's in a binary asset that it could just load quickly and have what it needs. And so that's the way that works. Our source assets are here, right, and they just get converted to this whenever they're imported. That being said, also, the KAF files do not get checked into the GitHub repo anymore. We only check in the source assets just as an example, and those get generated whenever you actually need them to be, right? Or whenever you actually reference them in code or configuration. So that is that. That is the way that our assets work. We have the import process set up. All that stuff's already in place. I just kind of wanted to quickly touch on that. And then the last bit of it is the OpenAL plugin. So I'm not going to go into this because we actually had a whole other stream where we talked about the way that the initial system worked, and the way that this new system works is not a whole lot different from this perspective. So let's see. Whoops, this is a dead file. This is the one we want now. OpenAL backend. These need to be deleted. I thought I got all of the old files. Apparently not. Okay. So OpenAL backend is what we need, right? So we've got all of our includes here at the top, all standard things you expect. And then let's see, why is this thinking we're on Windows for some reason? It's just my LSP that thinks we're on Windows. The build actually works as it's supposed to. That's kind of annoying. I'm gonna have to figure that out because this is the one that should be highlighted is these two guys. But anyway, let's see, because this should not even be. Yeah, see, that's highlighting all of it. Oh, because we are on Windows. I'm not on Linux. Jeez. What a dingus. I am actually on the window. All right, anyway. Ignore me. I need more coffee, apparently. I'm so used to coding on Linux that when I see Windows lit up, I'm like, why is that lit up? It's wrong. But it's not. It's me. Will this audio format support compression? Because if it will not, games will continue to consume tons of space. It will. It does not yet. But it will. So, yeah, obviously PCM files get big quickly. So, yeah, we're going to have to put audio compression in, but I didn't want to hold up the development of the game for that, right? Because that's just an import thing, and we can always very easily put that in place down the road. I also haven't decided what kind of compression I want to use yet. Something relatively simple is the goal. Okay. Do you have any async asset loading? If not, what situation would that bits be used in? So we wrote our asset system with that in mind. We've not done it yet. I have to Jobify it. That's the thing that's going to happen in the next release. But yeah, that is coming. So we actually even have flags when we make a resource request as to whether or not we want that to be asynchronous or not. So we can set that flag to be synchronous is actually what it says. It defaults to asynchronous, and then we can tell it we want this to be synchronous. We need the result to move on with our code. But yeah, we are going to have that. And the whole system's been designed around that with that in mind. All right. Okay, so there's that. One other thing I wanted to briefly talk about. Is I want to open up our water shader here, right? This is the fragment shader. And show you guys something. I'm just going to run this real quick. I'm going to have to pause the music again. All right, so we're going to load up the scene, and then I'm just going to move this off to the side and move this. I haven't actually tested this on Windows, but it works on Linux and Mac OS, so it should work here too. So if I wanted to change like the tint of the water or something like that, I can come in here and just change it, and it should reload. It looks like Windows didn't like that. That's awesome. Why is that happening? Interesting. So it worked on Windows, or it worked on Mac OS and Windows, or Mac OS and Linux rather, but not on Windows. So it looks like our hot reload is going to have to be changed a little bit. Got a bug there. Because it should have just looked like that, right? So that makes me wonder. All I did was change this. And it looks like it applied it, and it did it. But for some reason, that shader is all messed up now. Interesting. It almost looks like the shadow map is somehow screwed up. Okay. Well, that's not the point of tonight's video, so I'm going to come back to that. But we do have a hot reloading working. It looks like my shader system needs a little bit of work on that, though. So we have some bugs and stuff to figure out. Not a big deal. All right. So what we want to do tonight is we want to actually talk about emitters. And so typically the way that this stuff works, and we'll take a look at the scene to get started on that. Typically the way that this stuff works is if we have, let's see, resources that get loaded in, like static meshes or terrains or skyboxes or water planes, right? Those are resources that are loaded from disk. We do have some non-resources that are represented here, like directional lights and point lights, right? Those are just configuration only items. And so we're going to model our, well, I guess our audio emitters are kind of modeled after this, but kind of not also, right? It's not something we necessarily render, at least visually, but it is something that we have to represent, right? So we're going to need to add that. And also, like I said, we need to make a couple of small changes to the audio system to support spatial positioning. So I guess maybe that's where we should start. Audio front end. Let's see, was this actually implemented twice? I think it was. Channel volume gets. Yep, we did put it in there twice. Once just has the system and once doesn't. So yeah, we don't want the system version. Volume get. Nope, I don't want that one. I want volume get. This one. So these two right here, we're going to delete. And I don't even think the other one was actually exposed on the H file. I guess they are. All right. I'm going to take the comments, though, because those are actually useful. Let's see. That was the one from the set. I'm going to retain those. Let's see. State, channel index, and volume. Yep. Okay. And then we're going to get one for the get. All right, so we'll keep those and then nuke these two. We don't need these. All right, so we have a couple of other things in here that I eventually want to implement, but we don't necessarily need right now. We need a seek and a time played get and a length get. We'll implement those at some other point. But what I want to do is we actually have, so channel looping set and get. I don't actually want to be able to set here. So I actually want to delete these two because the more I think about it, the more it doesn't actually make sense to set this at channel level, right? It should be at the sound level, whether or not the sound actually loops or not. So that being said, we have a looping setting on the channel, but we also have a looping setting on the sound. So I'm actually going to remove this from the channel, and we're not going to support that anymore, which is probably going to give us an error in the update. Let's see. Just the creation, actually, of the audio channel. So we can get rid of that. And I guess the update was already doing what we needed it to for that. Let's see. Channel looping set looping comes from the bound data looping. Okay, perfect. All right, so the only other thing that we need to do then is we need the ability to set the position. Now, we also have this channel position here. I'm not going to have that either. This should actually be here. Right? That should actually be, position should actually be tied to a sound. And then audio channel, I'm actually wondering if we should not have the ability to change that on a channel either. It kind of makes more sense to pitch the individual sound. I don't know if it makes sense to pitch the entire channel. I think that's kind of dumb. Let's remove that too. So the only thing a channel should really have is volume, and then obviously a bound resource handle of something that's actually playing on that, right? So we don't have either of these, right? And then mixed pitch is just going to be just a single pitch, right? And actually, we don't even need that variable anymore. We can actually just do that. Okay. Now, position is going to come from the bound data. So that's going to be, channel bound data position, right? Which means we need to go to acquire, and we need to set a default position here. So that's going to be data position equals vector30, rather. Which technically speaking, this would have been zeroed out memory. So we would have gotten that by default, but let's be explicit and let's just always set that to 0. All right, so let's go here to where we have the K audio pitch set and get volume, looping, and we essentially want to follow the same format as these guys. So I'm actually going to take a copy of these, and we're going to say position get, right? And this is also going to be position. Okay. Let's see. So position get is going to return a vector3. And then what we'll do here is we'll return data position. And then if for some reason we call this with an invalid handle, right? We're going to do vector4 or vector30. And that's just going to be sort of our default fallback value if something goes wrong. Now here we need vec3 position, but if I can spell it correctly. Wow, I completely screwed that up. Position, there we go. All right, and so we need to say data position equals position, right? Okay, so that's all we need to have there, which is all well and good. Now, we have the ability to do that. That's automatically tied into our update loop. That's all we should have to do within the audio system. The rest of this is going to be basically setting up our scene to load up an emitter, defining what the emitter looks like, and so forth. Let's see. Pigo, first time chat, welcome. I am doing well. Thank you for asking. How are you doing? Weird Trash Can, good to see you as well. I hope you're doing well. Is because it's not correctly reloading into memory or whatnot, correctly applying. You mean the water flashing thing? Yeah, I'm not sure what that's about. That's the first time I've seen that. Like I said, it strangely enough, it worked on Mac OS and Linux, so I'm not sure why it's broken on Windows. I'll have to look at that. And actually, I think it might even be an NVIDIA issue, because I was testing it on my my AMD machine and it was fine there too. So I'll have to look into that a little bit further and see what that is. I'm not 100% sure. Some render doc captures will probably tell me. Story about compression. Set myself a challenge. Rewrite Minecraft Beta 1.7.3 server and Go, just to have an experience with this language. And packet 51 map chunk should be compressed. I looked at the spec for Java's inflator, deflator. It says that it uses zlib compression. No need to implement it in Go. Thanks, Mr. Notch. Nice. Yeah, I guess zlib might be a way to go, right? Seeing great progress since I was here last time. Yeah, we actually, we finally closed up the loop on that huge refactor branch. Solved a bunch of bugs. Still have some bugs to knock out. But the list is dwindling, for sure. All right, so now that this is done, I guess we can look at our scene. And let's see, directional lights and all this stuff is actually defined in our light system. I suppose it would make sense that our sound system maybe holds the type for that. Like maybe we do K audio audio types. Yeah, so like maybe we do that here, right? I guess that kind of makes sense, right? The only thing we have here now is just our backend interface and our backend config interface. So maybe we do type dev struct, and we'll call this a sound emitter, I guess. Audio emitter. Let's call it audio emitter, because it might technically be used for music too, right? It's not just sounds. All right. Now, what kind of things does a audio emitter need? Well, it's going to need a position, right? So vec3 position. It's going to need some sort of reference to a resource, right? Which we know are handles, right? So we have a K handle, and we're going to say audio, right? Handle to underlying resource. So we have that. I suppose we could do things like set the fall off, and we could set things like vec3 fall off, right? And we can always expand this, I guess. Let's actually just start with audio and position, right? Maybe we do. Actually, that's not going to be a vector3. That's just going to be a float. So this will, maybe tell us, how quickly the sound falls off. I don't know if a scalar is going to be enough to. Probably not. We're probably going to need a few different values for that, right? Kind of similar to what we'd have for point lights. right, where we can kind of define a curve. But for now, I guess we'll just have sort of a linear fall off. Somebody mentioned velocity, I think it was. What do we call that? I think it was velocity. Yeah, sound velocity. We don't have that implemented yet, but we could get to it. So maybe do vec3, vec3 velocity, right? And I want to mark these as to do. Implement this. Whoops. That's probably all we're going to need for right now, right? The most important thing for us to start is these first two things. Oh, I suppose we could also have, we technically could have a volume on this, right? But if we do have a volume on it, right, it's probably just going to be associated with, oh, you know what? We technically could have a fourth volume in the mix. Here's what I'm thinking on that. So we have a handle to an audio resource, right? Audio resources have their own states, right? One of those things includes volume, but that's resource-wide volume, not necessarily the volume of the emitter, which might also need to be multiplied in along with it. So we'll probably need a way to figure out what that should be. So I'm going to put F32 volume, right? And this is going to be emitter specific volume. And I'm thinking that maybe we have some sort of way to hook in an audio emitter into the audio system, right? For now, I'm not going to worry about that. I'm going to think about that for a little bit, but there's a few ways that we could actually tackle that. Dr. Elliott, how's it going? Good to see you. zlib could be a way to do it, but zlib is Go's stdlib uses Go's IO reader writer IO operations, which is not compatible with my interface and will not work with Minecraft protocol. Yeah, that sucks. Yeah, like I said, I haven't decided on what audio compression I want to use yet, so it's kind of like I need to do texture compression too. I haven't made a decision there yet either. Okay, this is good enough for us to have now. So I guess let's do this. Let's go to our internal lists of renderable objects, right? Which these aren't technically renderable, but whatever. So the way that these are, I don't think we need to have any metadata for them. I think we can just literally have kind of like what point lights are set up, right? So I think I'm just going to do this. And we're going to do darray of audio emitters, right? And this is going to be audio emitter. We don't need the struct tag. And then this is going to be audio, I guess we could say, yeah, audio emitters, right? I don't want to just say emitters because we're going to have particle emitters eventually too. An array of scene attachments for audio emitters, right? Scene attachment, this is going to be audio emitter attachments, right? So we have that. And now basically wherever, I'm going to say, wherever point lights is used in this entire thing, we're going to have to add something in there for, we're going to add it along with it, right? So I'm just going to do a find. That way I can find it later. It looks like there's 42 references to that. So I'm going to take this one, do emitters, audio emitters rather, audio emitter, right? And then we also need to do this, right? So out scene audio emitter attachments is an array of scene attachments, right? So that's kind of our lookup there. Okay, so let's go to the next usage of this, which is in scene destroy. So obviously we do need to take care of that as well. So let's not miss that. Audio emitters. And then also we have, oh, did we not get rid of the attachment arrays? What a dingus. Okay. I can't believe we didn't get rid of those. We'll say if s audio emitter attachments darray destroy s audio emitter attachments, right? God, do I really want to go through here and fix? I guess I have to do it. Yeah, I can't just leave it. I found it. I can't just leave it. Don't want to leak this, right? So skybox attachments. Let's fix this too. Directional light attachments. Point lights. Oops, point light attachments rather. Okay, audio emitters. So static meshes is going to be the next one. I think it's just mesh attachments. We need to rename that, but I won't do it in this pass. And then terrains, I guess that needs to be renamed to height map terrains as well. Right, and then water planes. We also have the metadata arrays for some of these. Let's see. I think everything but point lights and audio emitters has, and directional lights has it. So we actually need to go through here and just fix one more thing. So this, oops, did I not yank? I guess not. All right, so this needs to be skybox metadata. All right, directional lights don't have it, point lights don't have it, audio emitters don't have it, but meshes do. Terrains do. And water planes do. We might wind up having metadata for this. I haven't really figured that out yet, but we will cross that bridge when we come to it. All right, so next thing we need, scene node initialize. Okay, so here is what we do for point lights. And we're going to want something very similar for our nodes. However, we have these this node config, point light configs. We need to define these structures first, right? So we probably need to go to, let's see, where does this exist? Is this also scene node config? Yeah, we need to do some work here. So we need to define what this configuration object is going to look like. And we're also going to have to add this to the scene parser as well, so that when we deserialize this, we actually get what we're kind of expecting. So let's take point lights as an example again. And I'm just going to put this right below that. And node attachment, instead of point light, it's going to be audio emitter, right? And this is going to be audio emitter config. Okay, so we have a base. Does that actually contain a type? It does. Okay, so we need to actually add this and then come back. Okay, so we have unknown, skybox, directional light, point light, static mesh. Since we're doing everything right after point light, let's insert it in the middle of the list, right? So we're going to say, instead of that, we're going to say audio emitter, right? And then we also need to do this for the string lookup, right? So audio emitter, that's what it's going to look like in the config file, audio emitter. Okay. So we have that. The position is something that we're going to need, right? So that's going to be vector 3. We needed, I guess we could set volume in here, right? So we could just replace this with volume. I'm not going to put fall off in yet, or velocity, because we don't know exactly how those are going to get implemented. So I'm going to hold off on those. But what we do need is a way to actually get this handle, right? So we need a way to actually specify what resource is going to be loaded here. So what we need here is we need a K name, and we're going to say audio resource name. And then actually I'm just going to take this and copy it, and we're going to say audio resource package name, right? So we need to know, whoops, we need to know what resource we want to load and what package it's in, right? So those are the things that we're going to need in config, and then we can always increase it beyond that. So we're going to take a copy of this, put here, instead of point light configs, this is going to be audio emitter config, audio emitter configs, right? And this is going to be audio emitter attachment configs, right, for our nodes. So that way we have support for that in our scene configuration. And then what we'll do is we'll finish setting this up in the scene, and then we'll go ahead and head over to the serializer and implement that too. All right, so point lights. I'm just going to take this whole thing, and we're going to put this right before static meshes. Right, so this is going to be audio emitters, right? Audio emitter configs. We want to get the length of that, loop through the count. And then obviously we need to change our typed attachment config. So this is going to be audio emitter config. And then this needs to be audio emitter configs, sub I, okay? And now we have a new point light, right, which is sort of our template that we're basing it off of. And that eventually winds up getting potentially pushed into an array, right, depending on where we actually land. So we don't want to do point light here. We want to do audio. Actually, you know what? Let me do a rename on this. Oops, a rename. Now I'll fix the code first and then come back to that, actually. Let's change this to audio emitter, right? Do we need a name for this? We didn't think about that. I suppose an audio emitter could have a name, right? I suppose we could add that. That's easy enough to add. Right. So we have a name. So the other bits were, let's see, position, and then we need volume, right? And then we need to get like resource names, right? So audio resource name, and then we need audio package, resource package name, all right? And so these are going to be just resource name and package name, right? Don't need these two. We're not going to worry about a generation for this either, because it's not something that we have to sync with a renderer or something like that. Sound data is only uploaded once. We only care about that. So this is going to be position and then volume, right? So we set the name, position, and volume. Debug data. So debug data we need a structure to wrap this, actually. Now that I think about it. Okay. So debug data is like the little colored boxes that we have floating around for point lights. We need one of those for an audio emitter so we can actually see where the dang thing is in space, right? So we need that, but obviously we don't have a space to put scene debug data into this because it's just an audio emitter, which means we have our audio emitter structure here, but we're actually going to need a new structure that I think we can keep internal. So let's put it here, and we're going to do a type def struct scene audio emitter. Right, scene audio emitter. Right, and then internally, this is going to be audio emitter, and we're going to just call this data, because that's kind of what we did for some of the other structures as well. And then we're going to have, along with this, scene debug data. And we're going to dynamically allocate that so that we can say whether or not we have one just by looking for null. So we're going to say debug data, right? And so we should probably have this be a scene audio emitter, right? Which means that we need to do oops, hit the wrong button. Data for those, okay? And then we have, debug data here. We can create a box around it. Let's actually make this a little bit larger, right? Just so we can actually see it a little bit easier. Eventually we'll use like a billboard with like an icon on it or something like that, but we don't have that for right now. Debug box for an audio emitter, right? So xform position. So we have to set an xform for the debug box based off of the position of the emitter, right? So for our lights, we were actually using a vector 4 just because of padding and structure packing reasons. Here we don't actually have to do that, so we don't have that conversion that's required. We can just use the position as expected, right? Okay. Scene point lights. This needs to be scene emitters, or audio emitters, right? Let's also see, do we have any more? Yeah, audio emitters. And we're going to actually have to change the type on that from audio emitter to scene audio emitter. Isn't that what I called it? Oh, right. We do need a struct tag for that, right? So we're going to do struct scene audio emitter, right? We'll just forward declare that. Okay, so let's rename these variables real quick. We want to do new emitter. And then we have, let's make sure I didn't miss anything here. Debug blocks for audio emitter. Okay, point light count, this should be emitter count. All right, so how are we going to tell then? How are we going to tell if a audio emitter is in use, if a particular audio emitter slot is in use, right? Because we have generations on a lot of these things. Maybe we put generation in there just for that. Do we want to do that? I suppose I could also check for an invalid handle. And that would also do it, but I feel like a generation check might be a little bit faster. So I guess we can use generations. Fine. So if we find one that has a generation of invalid ID, we'll go ahead and use it. All right. No empty slot found, so push a new empty entry. So this needs to be audio emitters, scene audio emitter. And then we need a new attachment, right? So audio emitter attachments, push a new scene attachment. Then we set the new emitter, set up an attachment, resource handle based off the index, scene node attachment type. This is important. We need to set that to audio emitter. And we don't have metadata. Okay. So that is everything we need to do to initialize. And initialization isn't the same as loading, right? So we don't want to request the resource yet. We just are simply setting up some data, right? That being said, though, we need somewhere to store these, which is going to be in metadata. So I guess we do have to have metadata for these, because that gets loaded at a later stage, and I don't necessarily want to store that on the emitter itself. I suppose I could actually store it on the... In fact, let's just take this. Let's go here. Let's just add it here, right? We'll just store them there. That way we don't need the separate metadata. So we can do new emitter. Package name. That way we can access that later. It's not a big deal. All right, so next. This is the actual load, right? So we're going to do the same thing. We'll hook this up in a similar fashion. So obviously this means audio emitters, right? Let's just change all of these to audio emitter. Okay. Now we have light system point add, which adds just registers a point light to the light system. We don't obviously need to do that for an audio emitter, but what we do need to do is we do need to go ahead and load the resource at this point. So what we actually want to do is, I guess we'll do scene audio emitter equals this. Right? And then what we could do is we can actually request, we could say emitter, audio system. Oh, I don't have it included. Systems include audio front end. All right, so this is going to be audio system, audio system. Oh my god, I can't type tonight. Why don't we have acquire here? All right, so we need the audio system, which we probably ought to just store in the state, right? So we don't have to keep looking that up. Maybe not though. I guess it's load. We don't have to update it that much. Let's do audio system. So it's going to be k audio system state. Right. Pump that down in there. Put a struct tag on that. And now we can say audio state. What is the next? So it needs the resource name, the package name, whether or not it's streaming, and out audio. The is streaming is something we're probably going to have to hold in configuration as well. Which I don't know if we should auto detect that or not. We might want to eventually auto detect that. We'll have to see. Let's see. All right, so I guess we'll do emitter dot resource name, emitter dot package name, emitter is streaming, which we don't have yet, and then what was the last parameter? I think it was just the handle. Pointer to hold the handle. Yeah, okay. So we need the address of emitter data audio, right? And if this fails for some reason, then we need to basically do this, right? So we can get rid of that and that, bump that up, right? Okay, so failed to, let's see, acquire audio resource from audio system. And I guess at that point, there's not really much else we could do. Just warn and move on, right? Now, we do have this is streaming thing to consider. So let's actually go, let's go here and we'll go B8 is streaming. Right, and let's jump back up to where we were taking a copy of some of these properties. Let's see here, right? We also need to, in the configuration, why can I not? Interesting. My go-to definition doesn't seem to be working anymore. Oh, I hate when that happens. Okay. Relaunch Vim. There we go. Okay. So here we need a B8 is streaming. Right, and then here we can just say new emitter is streaming equals type attachment config is streaming. Right. Okay, this is where we left off. All right, so we need to rename this to emitter count, right? Okay, now, so we acquire the resource, the audio resource here, right? If that fails, we'll know about it. If it doesn't fail, then we'll load debug data if it was set up. That's just our box 3D. We just go ahead and we just load that, right? There's not really much else to explain there. All right, so that's the load. Now, the only other thing that I can think of is we're going to need a way to actually loop this as well, because emitters should play continuously, right? Well, maybe not, actually. Okay, we'll cross that bridge when we come to it. All right, so audio emitters, scene unload is going to have to also do some stuff once we get to actual unload. All right, so update point light debug boxes. We need similar logic for our emitters. Now, point light debug boxes, they follow the light around, but they also change according to the light's actual color. So if the light color is changing, the color of the debug box changes too. We don't necessarily need that, but audio emitters, right? So let's see. Looks like we have some weird things we need to figure out in here. Oops. So we set the position. The color set does not need to be done though, right? We just need to update the transform. We're just going to update that every frame. That's fine. Don't need this. There's a to-do in there. I'm not 100% sure what that's all about. Below method works, but the above does not. Hell if I know. I'll leave it there in case we circle back to it. All right. So essentially what we do is we build out the world matrix, right? Which actually, come to think of it, this isn't 100% working correctly either. So we need to actually investigate that, because I know for point lights it's actually wrong. So I guess I'll just do update the comment as well, right? Dot data position. Oh, we don't need to do this. Factory transform. Okay. You know what? I suppose we should actually just probably take this, because I don't think we need. I suppose we could use position down here. There. Okay. That should pretty much do it there. Let's see. This just needs to be audio emitter attachments. This needs to be renamed to emitter attachment. This needs to be renamed emitter count. All right, that should be it for that. So that's just the update, just to make sure that the box follows the emitter around if we actually move the emitter. Okay, render frame prepare. So this is just updating point light debug boxes again. This is just calling frame prepare. So this is basically going to do the vertex upload of the updated vertex data. This is essentially what that's doing in the head. So we just need to make sure to call that for our audio emitter debug boxes. Audio emitters. Okay, one more here. Let's see. Emitter counts. All right. Instead of point light attachments, audio emitter attachments. Okay, and I think the rest of this is fine. Okay. Debug render data query. Okay, so this is what goes through and grabs all of the debug data out of all the various things. I'm thinking about refactoring this at some point so that I can just put all the data debug datas in a single array and then just reference them by attachment index instead of doing all of this, because this is kind of annoying. But since this is what's here for now, I'm just going to copy pasta it, right? And I'll worry about refactoring it later. So audio emitters, This is going to be audio emitter debug data. There we go. Emitter counts. All right, here's the geometry data for that. Shouldn't have to change that at all. That should just be simple. Just toss it out to the renderer. Actual unload. Okay, so we definitely need to handle this as well. This is what actually performs the unload, because when you request a scene unload via hitting a key or something like that, it's actually a bit, it happens a bit after you do that, a couple frames afterwards, potentially. So we don't know right away. Audio emitter count. We don't know right away that's going to happen. So this is what gets called a few frames later, right? So audio emitters. I'll have to come back to that. I just want to update these. Next. Okay. Okay, destroy debug data. Now, technically speaking, we should unload the audio resource here. I guess at a minimum, we should stop the audio resource, right? So, I guess we can say audio audio system channel stop. So that's a bit of an interesting conundrum too, because technically, as far as OpenAL is concerned, and I'm pretty sure other sound systems work this way too, if I remember correctly. So play, stop, pause, resume work based off the channel that already have a sound bound to them, right? So you can't really effectively go, I want to stop this particular sound from playing. At least not directly. We have to actually make our API work that way, though, I think. Because unless I track what channel it's actually playing on and then stop the channel, there's not really a clean way to do that. I could pick a channel and just cache it, right? And then say stop the channel later on. But that feels kind of messy, right? It doesn't feel like good API design if I did that. I feel like I should be able to just say audio system stop. Here's the sound. I know what I'll do. Okay, so let's put a left off tag here. I know how I'll fix this. Let me put this in here real quick. Let's make this so that this code isn't completely hosed. All right, so what I'm going to wind up doing is we're gonna add. I guess we'll leave the channel stop stuff in there, right? But we're gonna add something else to our API to actually handle this for us. So this is only going to be a front end thing. We don't have to change our back end to support this. We're just going to make the front end do all the work, right? Which is kind of the way that it should handle anyway. So audio front end. Let's see. So what I want to do is we have the audio resource handle data, right? Oh, you know what? Shoot, though. There's a problem with that, too. What I was thinking was we could set a flag for the resource, right? To say, I want to stop playing this. The problem is, what if we have more than one sound emitter of the same sound playing in different locations? Then we can't necessarily do it this way. And actually, now I'm thinking these technically need to be independent of the resource, right? So what we really need, I wasn't thinking we're going to need instances, but we are going to need instances. So what do I mean by instance? Well, if we think about the way that materials and material instances work, a material is kind of the equivalent to our audio resource, right? It's what contains the base configuration, the base data, right? The base set of textures, the base whatever. In this case, we have the base set of audio, right? And obviously unique ID to go with that. The is streaming is probably something that also kind of qualifies for that, right? So this is sort of the base resource handle data, right? But an instance of that would be when we go to acquire a particular audio resource, we are also going to need to know, hey, for this particular resource, how many of these things do we have playing in the scene? Because we could have multiples of the same thing, right? Generally speaking, you're probably not going to run into that too much. You'll probably just have ones that sort of bounce around. It sort of depends on how you do it, right? You would probably only want to turn an audio emitter on when you're within range of it, right? Because otherwise, why have it play if you can't actually hear it? So we'll have to figure out, what the calculation is for that radius, right? And we'll just do a radius check on it, and we could say play or pause or switch or whatever. But if we have two different emitters that play the same sound and they overlap, right? They're going to have to be on different channels playing. Ooh, that could get messy. Or do we want to just say don't do that? This is one of those decisions. It's like how I decide to do this now could really have a knock-on effect down the road. So there's two ways we could do this. We could say don't do that, right? And then if we wind up having two sound emitters playing the same sound where their radii overlap, then we just pick whichever one is closer, or we just pick the first one or something and play it on that one and that one only, right? Generally speaking, you wouldn't necessarily want to do that anyways, right? Because it would kind of muddle the audio. But I could see where it could potentially be useful, maybe. So for example, if you're, I guess let's bust out the paint, right? Sorry for the flashbang. Give me a second. There we go. All right, so just thinking this out logically. Let's say you are here. Well, I need a thicker line than that. I can actually also use this. Let's go. Yeah, that's good. Let's say you're here, and this circle represents your hearing radius, right? Obviously, it's probably going to be much larger than that, but let's just, for the sake of example, let's say that. Now, let's say there are two NPCs firing weapons, I don't know, or doing something like this, right? I guess I have to draw it again. Right? And so they wind up kind of overlapping, right? So this is your hearing radius, right? There's a guy firing a weapon over here. There's a guy firing the same weapon over here. Theoretically, you should hear that sound on both sides, right? Technically speaking, you're not going to hear, this one on your left and this one on your right, but because they would be playing like this, you would have some overlap there. Ideally, you wouldn't really run into that scenario very much, but I think it is something that could happen. And so there are multiple ways to handle this. We could either say don't do that, which feels kind of like a crappy solution to me. Where if we did do that, we would essentially just pick one of them and play it, and then just not play the other one. Or we could try to play them both on separate channels, which is another option, right? And that seems like it's doable, but might not be as doable as you think. And the reason for that is I'm actually thinking, what if you have a situation like this, right? Where you have a whole bunch of things playing, right? You only have, say, 8 channels, right? Obviously, you could have more than that, but let's say you've configured 8. And you've got all these things playing, right? Is that acceptable, right? Yeah, the same sound from different emitters played close but in time but delayed, and that's another consideration, right? So probably the best solution would be this, right, where you have different channels for each one playing. Another thing you could do, and I'm not quite sure how I would make this work, right, is if it was like a repetitive sound that could be mixed, and I'm not thinking this is the right solution either, where the center of this sound is here, and the center of this sound is here, right? You average those, and you wind up with, somewhere like here. And you just play a single sound. Now, to me, that feels poopy, right? That doesn't feel right. Like, I feel like the right solution is to have these different sounds playing on different channels, because they could be further or along at different points in the sound, right? Especially if it's a long sound, it might be more noticeable. So then we say each emitter has its own channel, right? Which would have to be dynamically gotten from whatever's available at the time, right? And then, because if you had an emitter over here, let's say out here, right, and your listener is not within radius of that, this emitter can exist in the world, but it shouldn't start to play until it overlaps your radius, right? Until there's a collision on those, this shouldn't be just existing and playing, which is what's happening right now. And so we can definitely keep the number of channels down that way, the number of channels simultaneously used, right? And then I guess at some point, if you just have a ton of these things within your radius, right? At some point you just run out of channels and you can't play a sound, and that it just is what it is. Yeah, the problem with interpolating the sound, though, is like, especially if it's a longer sound, or like if it's, back to our original example of 2 NPCs firing a weapon, they're probably going to be firing those at different times and at different rates. So it doesn't really make sense to interpolate it either. So it gets a little bit weird, right? Doesn't OpenAL do mixing to allow for greater than 8 sounds? Yes. 8 was just an arbitrary number that I chose to, for this example. I think, though, it only guarantees 16 channels or 16 sources available. So, yeah. 16 is the limit that I've put in place, because, yeah, if the listener moves, it won't work out. Yeah, exactly. Right? So it gets and also, it's okay. So I think we're going to need a couple things, right? We're going to need, first off, to figure out a way to get this radius and whether or not we should be hearing it, right? And I'll have to look at the OpenAL docs to figure out how that is, how to get a radius from that, because I don't recall. How to set the fall off, some of those things. We don't have those things exposed yet. In addition to that, when a emitter comes into play, like into your range, right? Um, we need during that update loop to say, hey, start playing this thing on um, start playing this thing on a channel that you find if there's one available. And there's actually one more thing to consider, which is how far along the emitter is in its sound. So let's think of I've got that fire example, right? Or actually, no. Let's think of a radio as an example, right? You've got a radio playing, right? So this guy here is a radio, um, and so it's playing a song, and here you don't hear that song that's playing, right? Um, but when it comes into range, you can hear it, right? And then it goes back out of range and it stops playing, and then it comes back in range and it starts playing again. But it needs to make sense where that leaves off, right? Time needs to continue on that emitter playing, right? So it needs to continue moving the time forward, acting as if it's playing, even though it's not. And then when it comes back into range, it would need to say, okay, this is where I actually am in the time. Seek to that position and start playing. So we actually have quite a lot to figure out. This is not going to be quite as simple as I thought it was. But if we get it right, it's going to be awesome. So we have a lot to figure out, but I think we're going to start with just getting the positionals working first, playing all the time, and then we'll kind of add these other things in as we go. If you think on how multi-voice synth works, they have a set number of voice channels. Each trigger takes a voice for the required amount of time, and you have multiple strategies for how a new trigger will replace the older one. No replacement equals ignored, replace oldest. And you can sometimes say a track, sound here, can reserve a set number of channels and cycle through and reuse. Ooh, that's a good point too. So, reserving a channel is something I hadn't thought about. That's actually a really good point. Okay, so here's a good thing to think about when it comes to reserving channels. Lots of games have an audio score, right? Where they've got like some sort of music score running in the background. And when you're calm, it's just kind of, very, there's no enemies around or whatever. There's just some very calm music playing, maybe just some strings or something, right? No percussion or anything like that. And then when an enemy gets kind of close, it'll add another layer of music over top of that, synced along with it. You know, so maybe they'll get some drums added in or something like that, just to kind of amp up the music a little bit. The first track is still playing, but then you have that another layer on top of it. And then if a boss or a really hard fight comes in, you might have a third layer on top of that, and so you would actually have to reserve those channels to be able to handle playing those different layers. Because you wouldn't want to, you couldn't pre-mix that, right? So that's another thing we'd have to figure out too. So if you have environment, effects, dialogues, families of sounds, and a limiter number of channels, you can define a set of number of voices for each family, maybe priorities. These are all really, really good things to think about. I'm actually kind of excited about this. We can make a baller ass freaking system here. I'm really looking forward to it. All right. Like I said, though, I think we need to get basics first. But maybe let's think about some of these other things that we need to get in place. So, instances, for example, that's probably going to be the first thing we're going to want to put in place. More than anything else, we're going to want to put instances in so that we can have the same sound playing in more than one place. That's just something we should always probably be doing from the get-go, I'm thinking. So all of this would be instance data, right? Because maybe we have one instance of this particular resource that's looping and one that doesn't, and one that's at position A and one that's at position B, and they're at different volumes and different pitches, right? Pitch could be randomized. Like when you're mining something, the sound of the pickaxe hitting the node, right, could pitch up or down randomly. So this is all stuff that should be instance specific. So the way that I'm thinking about instances is we kind of follow the same pattern that we did for materials. Where we have a structure for this, and we're going to say K audio resource instance data, right? Instance data, right? And instance data has these things, right? And it also has its own unique ID. Right? Okay. And then what you have at this level is you have a K audio resource instance data instances, right? The array of instances of this resource, right? And so none of this is actually exposed outside the system, right? This is all internally kept. But this way we actually have now here's, let me think. So we basically need two handles for an audio resource, which is not a huge deal. We did this for materials, so we probably ought to put that in K audio types, right? So we have our audio emitter, and instead of having a single K handle, we're going to have one more thing. We're going to have a audio instance, right? And an audio instance is going to have a base resource handle and an instance handle, right? And then this becomes an audio instance, right? So our base resource points us to the internal resource, and then the instance points us to the particular instance of that thing. And then whenever we do anything within the audio API, we pass this instance. So we'll never actually be dealing with the base resource on its own. We'll just deal with an instance, which is a pairing of these two. Let's see. Pitch can simulate Doppler effect for moving objects too. Object coming at you, pitch raise, object going away, pitch decrease. Yes, that is true. Although, that's a really interesting point. We also do have the capability to control velocity in here of a sound. OpenAL does actually give us that. So that may be something we need to look into as well. All right. I actually need to take note of some of these ideas, or I'm gonna forget all of them. So let's do a new section for I guess I could put all of this into 080, right? Because we are going to need the sound system to start making the game. I may not do all of this right away either, but I want to at least get this down. Audio system, right? So K audio system refactor. That we can mark as done, just so we're clear on what we've done, right? So we need audio, whoops, instances. We need audio radius checks. Think emitter versus listener position / fall off. And then we need auto channel selection based on availability. Let's see. Oh, velocity was another thing. Audio velocity. Also, we should put here gracefully handle out of channels, i.e. discard oldest, or simply don't play. All right. Oh, I also want to get reverb in there. Maybe some other effects. Reverb is a good one to have, though. Let's see. Oh, I guess we could say channel reservation, sound types, or families. This one kind of goes under this one. Let's see, what else did we have? I think that might have been it. So again, we're gonna start simple. We're just gonna do position-based stuff for now. Get that working, and then we'll enhance it and start adding this stuff as we go. All right, so instances, we do need to make the audio system work with instances. Thankfully, that's not going to require any changes to the back end. We're going to handle all that stuff in the front end. So front end. Basically, our acquire and release are going to be changed to use an instance instead of just a straight up handle. And then, let's see. Audio is valid is probably going to have to, actually, I think all of these are going to be turned into instance functions. These channel ones can stay as they are. Yeah, okay. Actually, it's not too bad. It's just a few functions we have to do. So what we'll do here is instead of this, we'll do audio instance, and we'll say out audio instance. Sure. And then this is why I had instance here, because I was initially thinking I might need it, and then I was like, nah, I don't need it. I definitely need it. Audio instance, instance. right? Okay, so audio acquire is going to be audio instance, and we're going to rename this to out audio instance, okay? And then audio release is going to be the same thing. Let's just change that now. All right, so create a new handle for the instance. Okay. What we really need to do is we do have, so when we acquire this, we say this is the resource we want from this package. Ultimately, we need a way to say, does this combination exist anywhere? Which I think we actually have in here. Or do we not? I guess we don't store that, do we? We have k-resource audio, but I don't think that only gives us the name, actually. It doesn't give us the package name. So let's do, I guess we'll store the resource name, the resource name and the package name, right? And then we can actually do, instead of get new handle, we'll do get handle. And then we'll check to see if that base resource exists or needs to be requested, right? Because we didn't actually handle that here, which we should. This is requesting an asset or a resource every single time, which is not good. So what we should do is get new handle. Let's actually rename this to just get base handle, right? And what we want to do is, we'll do kname, resource name, kname, package name, right? And then what we'll do is we're actually going to iterate this twice, right? So we're going to do this bit if resource with name, package name, combo not found, need to request new, right? So what we're going to do first is we're actually going to loop through this. Search for name, package name, combo, and return if found. And since k-names are just integers, it's going to be super fast to search this, right? So literally all we have to do is come in here and say if data resource name equals resource name and data package name equals package name, then we're going to do a return k handle create with a U64 identifier. And so the handle index is going to be I, and then the unique ID is going to be data unique ID. Right? If that's the case, found and match, return. Whoops. All right. And so we'll search to see if one exists first, which is why I renamed that to get base handle instead of new handle. So it'll either return the handle of one that already exists, or it will return a new handle. One thing I'm going to do, because how are we going to know which handle it returned, right? It's always going to be a valid handle. If we're creating a new one, I'm going to say data resource, which is just, oh wait, that's going to be, let's just make sure resource is zeroed out, right? So what we can do is we can check that to see, hey, do we have a resource? And if we don't, then we know that it's a new handle. If we do already have one, then that means it's already loaded. We don't need to request anything. So we can go here, and we can say out audio instance, base resource is that, right? And we'll pass along the resource name and the package name, right? And then we'll do if not, let's see. Oh, I suppose we ought to do this first, right? This needs to be out audio instance, base resource, handle index, right? So if not data resource, then we do all of this stuff, right? Otherwise, we just need to get an instance of it, right? Let's see. Audio instance play position does not depend on ability to hear it. Oh, yeah, that's a good point. How do I... Audio instance play position versus listener. Well, play position plus radius versus listener plus radius indicates if currently bound playing on a channel. I'll know what that means. Okay, so if we don't have the resource, then that means new handle was created, need to request resource. And at that point, we can actually even say data package name equals package name, and data resource name equals resource name, right? Mark the slot as in use by syncing the unique ID. Didn't we already do that in here? Yes, we already did that. All right, so we're just doing that twice. We don't need to do that. Okay. Now, reasonable defaults for an instance, right? So this is going to be a to-do. We're going to take this and we're going to put it all the way down here. To-do instances, all right? So the listener audio is going to be, let me think about this now. we actually need the instance to be passed along with this, because I think when we actually get... Actually, do we? Or is it just the base audio instance? I think we can just pass... I think we can literally just pass base resource here. I don't think we have to track the whole handle. Yeah, that should be fine. Okay. So here's where we request the resource. So here we're going to say if this fails, failed to request audio resource, see logs for details, and we'll return false here. But we don't want to return if it's successful. What we'll do after this, because I don't think... Oh, we should probably also free the listener. So we could do size of audio asset request listener. I don't know that I've got that right, but and I guess that's resource. Okay. So if we get past this point, right, the resource request was successful. Now we want to create for the instances, the D array for the instances. Doing it before is kind of pointless, right? Because then we have to just, it's another thing we have to free. So this is just kicking off the request, by the way. If kicking off the request was successful, then it'll continue to do this. It doesn't necessarily mean that's loaded yet. But it's enough that we can start creating instances and then check it later. So we can do assets, wait a minute, data instances equals darray create. And that's going to be did I call that audio? No, it wasn't audio instance. What the heck did I call it? Resource instance data. Audio resource instance data. I don't know why my IntelliSense isn't picking that up, but did I get it wrong? Oh, K audio, I guess. What is this bleating about? Oh, we don't have containers darray. Yeah, okay. All right, so we create the instances array. And we can just, since we're dealing with handles, we don't have to like pre-allocate any space or anything like that. We can just do that. Yeah, that's fine. All right, so the next thing that we need to do is actually get an instance handle. And I think this is the only place we have to do it. So we're just going to do it in line. Check to see if there is a free instance slot first. Otherwise, push a new one. Thank you for the follow, by the way. Appreciate that. Line 277 does is streaming true false. Isn't that the same as is streaming? Yes, it is. Yeah. I don't know why I did that. I think I was trying to be explicit about it, just to make it super, super obvious, but yeah, it's technically... It's just that. Yeah. From good to see you. How's it going? I know I'm a little bit late over there on that side, but yeah. All right. Let's knock out this loop really quickly. So, U32 instance count, array length. And this is going to be data instances. For U32 I equals 0, I is less than instance count plus I. All right. I guess I could just go ahead and grab a pointer to this. So K audio resource instance data instance equals the address of data instances sub I. Oops. If instance, and so we're going to look at the unique ID for this to determine if it's available. So if the unique ID is invalid ID U64, then it's available. What we could do at that point is we'll have an index, right? So I guess we could do U32 resource index. You know what? Actually, let's do this. We're going to default to that scenario. We're basically going to say that the resource index is going to be inserted at the end of the array, right? And so by default, it's going to be the length of that, which will be also the index once we insert one. And then we'll overwrite that if we find one that's available. So we'll say resource index equals resource index equals I, and then break. Should I do that, or you know what? I'm going to separate it out. Before I do that, let me rename this one back to resource index equals invalid ID. Then we can actually tell, whoops, then we can actually tell whether or not we found one. Okay, so I can just do if resource index equals invalid ID. Why is it all the way down there? Okay. Then push a new one. Right? And so we'll do darray push data instances, and we're just going to push an empty thing, right? So we're going to say k resource instance data, right? And we're just going to cast that to it, right? We're just going to push an empty object in there, and we're going to say that the resource index equals instance count, right? And so that'll basically point us to the last index of that array, which this one would be. Push a new one if one was not found. Right? Okay. So at this point, we can actually get a pointer to the instance So now we can say kaudio resource instance data instance equals the address of data instances sub resource index, right? And now we actually have that instance pointer. And so what we can do at this point is we have the resource index that we need also. So we can create a new handle. We'll say instance, let's do it this way. Let's do out audio instance equals k handle create, and we just want the base create on that one. We'll do resource index, and then we'll do instance unique ID equals out audio instance I thought it wasn't that called instance? Wasn't it out audio instance? I thought it was. Yeah. Why is that flaking out on me? Instance. Not handle. Unique ID. Unique ID. Do I have that right? LSP died again. Apparently shouldn't have updated that. All right. So now we can actually replace these with instance. And then when we're all done here, we return true. Okay. I think I got that right. For now, anyway. Okay. So that is how we are going to acquire an instance, and then releasing it is a little bit simpler. So we obviously need instance here. Boy, my LSP is just failing left and right. Let's see, I guess restart, maybe. Okay, so we actually need to check handle is valid and pristine against the base. Check both instance and base handle. And that's where we're going to pick up on the next stream, because I just looked at the time and we're over time because I have to get up early in the morning. Yeah, real LRK. I appreciate you participating for sure. And yeah, we're going to get back to this tomorrow night. So thank you guys all for being here. We are going to find somebody to raid. If you haven't already, I would encourage you to follow along with the project. I would greatly appreciate it, A. And B, if you guys want to see us actually make a game with this, we're going to be doing that here as soon as we get these audio emitters in. Because I think that's going to be one of the last steps that we need to actually... And we actually did a bunch of discovery tonight, too, on that, which was kind of awesome. Let's see. Same category. All right, so I think I'm going to send you guys over to I'm going to send you guys over to Jitspo. He's making a pretty neat looking retro FPS. Um, and I really like the way that it's kind of coming along. It's a really cool looking game. So looks like he's doing some modeling right now and animation, but yeah, he might be able to run it for you guys and show you what he's got so far. So definitely ask him about that. Ask him about throwing books at things because that's a mechanic he put in place that I think is super awesome. And yeah, that's going to do it for tonight's stream. So thank you guys so much for being here. I really appreciate you guys. And I will catch you guys on uh, the next stream.